Okay, I just have one example for you today because, like I said, we got a short little day. Give you one more little example tomorrow. Do you guys know how to use a compass?
Yeah.
What type of compass?
You think you know how to use a compass? We'll find out tomorrow. Anyway, today, one triangle. Angle A, 16 degrees. Little a, which is opposite angle A, is 8, whatever units it is. And little c, is that the angle or the side length? Side length, it's a little letter, is 12. I want you to draw this. I will get you started just so we're relatively consistent from person to person. Down here is going to be angle A. Okay, that's about 16 degrees. I want you to put little c here on the top, which is 12. I want you to finish drawing that. Well, you finish drawing it, then there's going to be 3 angles because it's a triangle. But. Okay? Just make C on the top. That means opposite this side. Angle C is going to be down there, which means angle B's got to be on the top, right? You know how long C is. Make it as accurate as possible. If 12 is little c, then A, the side opposite angle A, is 8. It's got to be about 2/3 as long, right? Got it? Got it? Got it? Couple more minutes. What were we doing yesterday? Something about triangles? Affirmative. That wasn't the A word we had. We had a different A word yesterday.
Ambiguous.
Ambiguous. So, I'm going to draw that. That's C. That's 12. And opposite angle A is 8. Whose looks like that? Couple of you? Okay, let's do it again. Don't erase it. Don't. Okay, we got 2 triangles here. This is 16 degrees. That's angle A. That's going to be 12 again. And this is going to be 8. Whose looks like that? No? Everybody's looks like that? Well, what else would it look like?
Do you have to have it?
Well, that's how, did you do it like this? You made a right angle triangle, assuming you had a right angle?
No.
Okay, well, at this point, you don't know that that's wrong. It's just, that kind of looks like, well, I guess that could do it. I don't know. Well, there's no real wrong here, okay? Again, I asked you to draw it. We could have a few different possibilities. But here's the 2 possibilities I want. So you're saying some of you guys did this, and you just went, wah, right? Is that what it looks like? The rest of yous? Okay, well, I'm not saying that's wrong, okay? But is this a little ambiguous? If you actually had a ruler and measured, like, there's 2 choices for where you put this, actually, and I guess there's 3. Maybe it is vertical. Maybe that could be a right angle triangle. I could figure that out, couldn't I? I could use some ratio to figure out what the sine of 16 degrees is, and I could calculate what that is. And guess what we're going to do when you guys get back from break? Exactly what I just said there. Okay? So, let's solve for angle C. First, I want to do this guy, okay? So, let's do that. How do I solve this for angle C? Do I want to use cosine law or sine law? Correct. Because I don't have three sides, that's when I want to use cosine. Or I don't have side, angle, side, right? I don't have two sides and the angle in between them. So I can't use cosine law here. I'm going to use sine law. Okay, so angle C, there's this opposite stuff going on. I know this opposite angle is side 8. So let's go put the angle on top because I'm solving for an angle. Sine 16 over 8 equals this opposite stuff. Sine C, that's what I'm trying to find, over 12. Comprende? C. Everybody good? Okay, so what do I do next? I could, but I don't have to, because I was thinking and I put the angle on top because I know I'm solving for an angle. So all I got to do to get sine C by itself is what? Just multiply both sides by 12, right? 12 divided by 12, it's gone. You don't have to make that sound effect. Okay, 12 times sine 16 divided by 8 is sine of C. So angle C is, once you're in degrees, the inverse sine of all that stuff which is 24.4 degrees. So angle C, this tells me it's 24.4. So, those of you who did this triangle, does that look reasonable? That's definitely not 24 degrees, is it? Okay, so but that's fine. Don't worry about it. Does this kind of look okay for 24 degrees? All right. Those of you who drew this, does that look okay? So now we're going to solve it again. This was solved for triangle 1. That is also an option. There's nothing wrong with this. If I pulled out a ruler, I had this graph paper, and I exactly measured that to be 12. That's exactly 8. I pulled out a protractor, and that's exactly 16. That is one possibility for this triangle. This is also a possibility for this triangle. Okay, it's ambiguous. So that's correct. How do I solve for that one? What would this angle be? Good, good. For angle 2, then this angle, angle C, is 180 minus 24.4, which is exactly 155.6. Okay? That's just as correct as that. Righty? Now what happens if this said solve? I would have, again, two possibilities for angle B, wouldn't I? Because if this angle's different for C, then obviously that angle B has got to be different. How many obtuse angles can you have in a triangle? Yeah. If you have more than one obtuse angle, how on earth could you ever have three sides that actually join? You thought about that? Picture it in your head. Visualize it. Yeah. Okay? So if this one's obtuse, B can't be obtuse. It has to be something different. You guys know how to solve for B. It has to add up to 180, all three angles. Then you just solve for B, right? Okay? So two possibilities for that. First, I want you to do 173:15. Read it carefully. I don't think it says solve. I think it says explain how to solve. And then quiz review. I know it's just a quiz, not a test, but this is the next thing in our book. So let's, hey, why not, right? Let's do it. 1, A and D, 3, 5, 6, and 8. And after the quiz tomorrow, I'll just give you another example and a couple more questions. Okay, that's it for today. All right, so quiz tomorrow, it'll look like these questions here. Okay, so obviously you want to do that for tomorrow. And you got 35 minutes to get it done. So get her done.